topic of multiplying rational expressions. I just want to remind you of your work with fractions, because rational expressions are just algebraic fractions. So, like when we worked with a fraction like this problem where we said 5 went into 5 once and into 25 5 times, and 7 goes into 7 once and into 14 2 times, and then multiplied. In this case, 1 times 2 is 2, and 1 times 5 is 5, and we were done. When we work with rational expressions, algebraic expressions, we will factor and then remove common factors like we have in this. Multiplying rational expressions, you need to remember that you have to factor everything first. Again, almost everything in the work that you're going to do with rational expressions is going to be involving a lot of factoring. This is a monomial, and so is this. I don't need to try to factor those. You know, I could call this 2 times 5, and I could call this 2 times 3 times 5. I'm not going to do that. I'm only going to factor expressions that are 2 terms or more. In this case, a binomial, and I'm going to take the common factor of 6 out of those terms. And here I'm going to take a common factor of 20 out of those terms. Now, it's not necessary that I do this, but I'm going to rewrite these. I'm going to put the numerical factors in front. In other words, this 10t and this 30t cubed, because I will likely reduce those together, I'm going to put those, again, one's on the top, one's on the bottom. It's all right for me to do that. This 20 times t minus 2, and this 6 times t minus 2 are likely to be reduced. So I'm going to go ahead now and reduce. I just need to have a common factor, one on top, one on the bottom. Here, a 10 goes into here once, and a 10 goes into here 3 times. I will come back and reduce that right there. Those are common bases. Remember that you subtract their exponents. So you could say that that's equal to t to the negative 2, or instead immediately say that that's going to be t to the positive 2 downstairs. I'm going to also reduce the 2 out of each of these. So 2 goes in here 3 times, and 2 goes into here 10 times. Finally, I might even do this too, if this helps. Take out the t to the first, take out one of those, and remember that that exponent is going to have to be t squared downstairs. So in the numerator, all I can see that I'm left with is a 10. And in the denominator, be real careful. I've got 3 times 3, which is 9, and t to the second power. Everything else has been reduced. These are all ones. Again, or I've reduced that to 1/3. This is my expression for the process of multiplying those 2 rational expressions. I'm going to multiply these 2 rational expressions. What I want to be careful of is to first factor everything first. So this expression right here has a common factor of 5. Notice that I'm factoring up above and sometimes down below of these fractions. It just makes my work easier. I use a little bit less paper, and my board here is actually quite small. I cannot factor that at all, so I will write that as a binomial, v minus 2. And then over here, this trinomial needs to be factored into the product of 2 binomials, where in the front of each is a v. I want the last 2 values to have a product of a positive 4, yet they have to add to be a negative 4, so I'll need 2 minus signs. They'll both have to be 2's, because a minus 2 times a minus 2 is a positive 4, and a minus 2 and a minus 2 adds to be a negative 4, so that's factored. And then down here I have the difference of squares, a v plus 1 in one of them, and a v minus 1 in the other. Now if you don't want to, you don't have to take this next step. People often just start reducing this v plus 1 and that v plus 1. One of these v minus 2's with that v minus 2. I'll just write it, and I won't always be able to do this, but I have the space right here. Here's the numerator. Here's the denominator of the first fraction. The numerator of the first fraction, and the denominator, I'm sorry, this is the second fraction, I hope I said that a minute ago. Make sure you've copied everything. That's the dilemma with copying things. This is a common factor. You have to have one on the top and one on the bottom in order to reduce it. They can be kitty corner or they can be up and down. I have a v minus 2 and a v minus 2. I will remove those as well. Finally, my answer is what's left. Even though this is called multiplication, we never truly multiply. I have a 5 right here and this v minus 2. You will not be expected to multiply that out or to distribute it. Downstairs, I have a v minus 1. The bottom line is there are nothing I can reduce left at this point. This is how I will leave my answer. This problem has a couple of expressions that needed to be factored several times before I'm complete. Whatever you do, don't forget that broken record of mine. Always take the greatest common factor out first. So let's start with this numerator. The greatest common factor is a 2. I'll factor that out, and just that, and I'll need here a t squared and a minus 49, because 2 times 49 is at 98. Remember that if you get two terms with a minus sign in between, you need to keep going. And in this case, I'm going to factor that into t plus 7 times t minus 7, and I'm not going to forget to bring my 2 up. This is the factored form of this numerator. Down here in the denominator, I need to take the greatest common factor of 4 out first. And when I do, I'll have a t squared minus 1. This has got to be factored again into the product of two binomials, t plus 1 and t minus 1. Bring that 4 down. Again, I'm looking at this, and this is my factored form of the numerator and denominator. This numerator can only have an 8 factored out of it, and when I do, I'll need a t plus 1. And I'm afraid that I meant, no I did not. This one, I want to take the 16 out, and I believe I'm going to need a t minus 7 to factor that. Now I'm running out of room here to rewrite this problem, so I'm going to go ahead and do what I would normally do it if I were working this on my own anyway. I'm going to note that this is my numerator and denominator for the first fraction. This is my numerator and denominator for my second fraction. And I'm going to remove common factors of 1. So I see, I always look for binomials first for some reason. There's t minus 7, 1 on the top, 1 on the bottom. Here's t plus 1, 1 on the top, 1 on the bottom. I think I'm going to go ahead and reduce this 4, and it doesn't really matter at all. I'm going to reduce the 4 into this 8. So 4 goes into here once, and 4 goes into here 2 times. And then finally, I'm going to reduce this 2 and this 16. I'm going to say 2 goes into here once, and 2 goes into here 8 times. Got to be really careful. I do not see any more binomials that can be reduced. For example, this t plus 7 and this t minus 1, they cannot be reduced. Oh, I do see, I just noticed this, the 2 and the 8. Again, if I didn't catch it just now, I could do it later. 2 goes into here once, and 2 goes into here 4 times. So I've gotten rid of my numerical factors upstairs. I have 1's left in this t plus 7. So my answer is going to have in the numerator just a t plus 7. You could put a 1 out in front if you wanted. It's not necessary. Down here, I have this binomial, nothing else but a 1 times this t minus 1. I have this 4. So I have a 4 times t minus 1. And this cannot be reduced anymore. At least I've noticed I've caught everything. A little bit hairy, got to be careful. All these 2's and 8's and 16's and 4's, you got to be careful not to do too much at once or to miss anything. Or if you do at the end, come back and catch it later. We have multiplied. Never did we really do any multiplication. We factored and factored and factored and factored and factored and removed common factors. My intermediate algebra students, here's a problem that involves the difference of cubes. Same process. Multiplying rational expressions involves factoring first. So right here I have the difference of squares. So I'm going to factor that into 2x plus 3y times 2x minus 3y. Down here, the difference of cubes, you're going to have to remember that if I took the cube root of 8, I would have a 2. And the cube root of x is x. This is the expression 2x that I would cube to get that 8x cubed. And likewise, I would take a 3y and cube it to get a 27y cubed. Those two parts are what go into this equation that I have memorized, which says that you should take, when you're doing the difference of cubes, this 2x minus 3y, and then you'll create a trinomial. It will be this first term squared. 2x times 2x is 4x squared. I memorized this because here's a minus, this is a minus, then this term is going to be a plus. It's the product of these two. 2x times 3y is 6xy. Always these end with a plus sign. It's this last term squared. 3y times 3y is 9y squared. That's factored. That's the factored form of difference of cubes. It happens to be that I notice this one is a perfect square trinomial. I notice that I'm going to need a 2x in the front of each of these because their product is 4x squared. I'm going to need a 3y in the back of each of these because their product is 3y squared. And I happen to notice that the inner, which is 6xy, and the outer, which is 6xy, adds to be 12xy. That tells me that I want plus signs in both of these. Because this factors into the product of these two binomials, I'm fairly aware of the fact that this doesn't factor then, because it's almost the exact same thing. It's got a 4x squared like this, it's got a 9y squared like this, and this 6 will keep it from being factorable. And the other thing that I notice is down here I have a trinomial that's exactly like this numerator. So I'm done. I can think of that as itself times 1, and I'm fortunate enough now to be able to cross this whole trinomial off because I have one on top and one on the bottom. I'm going to keep removing common factors. Don't forget, when you remove these, what you've done is left behind a 1 in its place. So next I'm going to take out a 2x plus 3y and a 2x plus 3y. I'm going to start throwing some 1s in here. A 2x minus 3y and a 2x minus 3y. Some 1s. And the reason I did this time is because everything got crossed off in the numerator. And I need you to recognize that you have 1 times 1 times 1 in your answer, or 1 in the numerator. And downstairs here, 1 times 1 times 1 times 2x plus 3y, or I'm just going to put that 2x plus 3y. And there's my final results. We're going to go on next to dividing rational expressions.